Hi, welcome to Exam Debug. I'm Chris McKenna, and today we're going to be going through microprocessor controlled devices. So, this is a really important topic. It comes up again and again in the IGCSE ICT, so it's really important that you know this one. So, in order to illustrate, I've made this little Scratch program. Now, you can go and you can check this out, and you can just use the Scratch program by yourself. It has a little tutorial going on. But this is the sort of DVD commentary version. So if you want something to listen to, because I haven't put audio on it, then you can continue on with the video. Otherwise, the link is below. So let's get started. Okay, so this is Giga, and he or she, the androgynous Giga, is going to take us through this process. I'm going to slow it down a little, just so that I can talk over it. Okay, so Giga is kind of hot, and she wants to use, I'm assuming it's she, wants to use the air conditioner. So she goes inside, in a moment, maybe too slow, she goes inside to take it apart and see what's going on with it. Alright. So, and she discovers that it is a microprocessor controlled system. And as she mentions, you get these in many, many different places. So, heating system in your house, or in a greenhouse, the controlling system for that, probably also temperature or other things, and for monitoring patients. So, could be other things. There's a whole bunch of different examples, but the ones that come up in the IGCSE most often were the ones that were just mentioned there. So, sorry, I've got an option here. Do I want to repeat? Oh, so go on. So, we have a keypad here, and we use this to store our temperature. So, when the room gets to that temperature, the air conditioner will be turned on in order to cool the place down. So let's say, for example, I want to set it to 5 degrees, which is quite cold, but because I'm starting at 0, I don't want to have to jump up to spend too long turning on things on and off. So let's set it to 5. She enters 5 on the keypad, and that number is sent to our microprocessor. And what you'll see here is the microprocessor will store this in its saved location, whatever that may be. So it has a way of saving information. Or, as it mentions here, in some cases you might not have this input option. In some cases it might be a preset value. But it's easier to think of, at some point somebody had to program in a value that must be met before something happens. Alright, no again. This could get mildly annoying, but it's just so that people can continue if they want. Okay, and then we have this sensor. So the sensors are really important. These help us read physical world information. And there are lots of different types used in a whole bunch of machines, used in robots. Could be for light, sound, heat, other things like that. However, the thing is about sensors is they read analog data. Okay, so which is kind of real world information. It doesn't have a set point. But we have to change things into digital. And in order to use digital, we have to use ADC, or analog to digital converter. So this takes the analog information from the sensor and converts it into digital here, so that the microprocessor can understand what's going on. Yeah, so like temperature is not stored as set values. Temperatures can be fractions, it can be tiny numbers. It's all based on these waves. And so computers can't handle that. They have to have marked limits. And so to change it to those marked limits, like 0, 1, 1, 0, then we need this analog to digital converter. Okay, so then we have our microprocessor. Because, as we mentioned in the other videos, it's going to be our brain going on here. And in this case, part of its program is to check the sensor data. And it's going to be checking the sensor data against the stored value. So what's going to happen is this number is going to come in, or the sensor is continuously reading. Its values are converted from analog to digital, and the value comes to the microprocessor. Now, as you'll see, if the temperature gets a little bit hotter, for example, it's converted into digital and is compared. Now, the microprocessor is saying the temperature is fine, so we've said we want the AC to go on once it gets to 5 degrees. And in this case, it's still lower than 5 degrees, so it's not going to do anything yet. But what happens if we go up again? 4, no, 4 and 5, temperature is still fine. Okay, now we go up to 5, comparing 5 and 5, it's too hot. So then we're going to send the signal to turn on the motor. So if it's a stored value or greater, the signal is sent down to our motor in order to get things going. But to do that, we have to have the opposite. We have to have a digital to analog converter, which is going to allow us to control things which have analog details. Okay, so remember, this is a continuous process. It's going to keep going forever. If you're using the thing, you've got an auto button here, so it's going to keep checking at regular intervals. So it's not that it checks once and stops. This is a continuous process. So if we go up, comparing 6 and 5, it's still too hot, so nothing's going to happen. If we go down the way, 4, comparing 4 and 5, the temperature is fine now, so we want to turn off the air conditioner. So we send the signal through to the DAC, the DAC converts it so that we can run the analog motor, or turn off the motor in this case. Okay, so that's everything there. So we'll just review that in a moment once she finishes selling you the YouTube channel and website. Sorry for that. Becomes a bit of a habit. Of course, at this point, feel free to subscribe if you'd like. Okay, so let's just run through that again. So what we have going on here is we have the temperature and we can set the value. So we can set the value, let's say 6 degrees this time. So in my remote control for my air conditioner, I put in 6 degrees to turn on. And then that signal is, it's kind of slow, is sent and stored here. Okay. And now what's going to happen, I'm going to click the auto button this time. So this is going to keep happening for indefinite period of time until we turn off our machine. So it's going to keep sending the signal and it's going to keep comparing until something changes. So let's say we change the temperature outside to 6. We're comparing 6 and 6, and it's too hot, so the microprocessor is going to send the signal to the digital analog converter and it's going to turn on the motor. Okay, so hopefully that makes sense to you. It's like I said, it's a big thing that often comes up, and your key points here are we have a microprocessor and it has access to some kind of stored value. We have sensors which read analog data from the real world. You may have to identify which type of sensor it is. It's often a key point. It could be a temperature sensor, a pH sensor. But we have these reading data and they have to be converted. This information has to be converted using an analog to digital converter so that the microprocessor can understand it. This is then compared with the value in the database, or database, could be a database, compared with the value that's been stored. And then if it makes a certain value, then what's going to happen is it's going to then send a signal to some kind of device, in our case a motor, but it could be absolutely anything at all. Well, not anything, but it could be any kind of controllable device. Okay, so hopefully that helps. If you have any questions, please comment below, and of course subscribe, as Giga's already told you to. And if you want to play about with this yourself, you can check it out on Scratch. Might be really cool if you're maybe a bit challenging, but why not try and make your own version of this, or do the mix-up version of this in Scratch. And if you're new to Scratch, it's definitely something really worth learning. It's a good place to start programming, and it's free. Okay, so thanks very much, and good luck with your exams.